Welcome to Rasa Chats, a biweekly podcast about conversational AI where we talk about open source, applied research, and how our community of makers is building accessible AI. I'm Mady Mantha from Raza, and I'm your host. And today we're talking to Hamel Husain from Github about making machine learning work in production. All right, Hamel, thanks for joining us and for taking the time to talk to us. Welcome to Rasa Chats.
Thanks for having me.
Yeah, I want to kick things off and introduce the topic for today's episode, machine learning ops. Obviously, it's a huge field. So in your opinion, how would you define it, and what are the different steps you go through when you're pipelining and releasing machine learning applications into the real world?
Yeah, I would describe machine learning ops as analogous to a DevOps. So DevOps is a kind of a discipline paired with traditional software engineering that helps with kind of the software engineering life cycle of testing, deploying software, monitoring that, making sure it's reliable and performant, and that people can. There's a low friction to iterating on these things, and that tooling has matured over a kind of a long period of time. And I would say the field of DevOps is really the mainstream of DevOps is really focused on a lot of times things like web apps, like how to deploy a website or an application, perhaps backed by microservices and things like that. But it turns out that machine learning systems require something very similar, but the requirements can often be very different because, obviously machine learning systems are very different than web apps. And even the underlying microservices might be very different in terms of their compute and the workflow that goes into that. So ML ops really tries to take the concept of DevOps and create something analogous to that for machine learning, so that machine learning people can also iterate faster, have tools to deploy machine learning into production, monitor that, do it with the kind of lower friction and things like that. And there is a fair amount of overlap between traditional DevOps and ML ops, such that not to reinvent the wheel where it's not necessary, and also to try to use existing technology where it makes sense. But there are some new things that maybe don't exist today or that are newer. And I think people are still defining like what ML ops really means. As far as the pipeline is concerned, I don't know if I want to get into defining a machine learning pipeline. I guess that's kind of maybe a boring topic or something that's very mundane in the terms of people. I don't want to describe like what a typical machine learning pipeline is, because it's very different for a lot of people, but it generally is consists of something like acquiring data, cleaning it, iterating on some type of model, and then productionizing that model, and then going through several iterative loops of that to really oversimplify it. But that's generally how I think about it.
Okay, cool. What do you think are the trickiest parts to get right when you're pipelining a machine learning application? Something that's might be different for a regular software application, do you think?
I think a lot of it can be tricky along the way. And it depends upon the organization and the circumstance. I've seen people struggle with all various different steps in the journey of trying to produce a data product. The part where I actually see it fail the most often, or where struggles happen that are of the greatest consequence, is actually at the very beginning in the formulation stage. People scoping what this data product should look like. What goal does it serve? Is it really going to sort of move the needle on anything that the company really cares about, or is it more of a vanity project to allow someone to say that they use machine learning in X? And being really getting that defining that very crisply and doing that really well is actually very hard. And I think that's where a lot of projects fail in my experience, because they don't define that crisply enough, or they're not honest with themselves to say this is something the company cares about, and eventually the project doesn't have enough funding to be successful. Because at the end of the day, a lot of times machine learning can be very expensive. It takes an enormous amount of time and resources to pull off a data product often. And you need certain amount of buy-in to beyond just words to be able to accomplish that. And if the product you're building doesn't actually further a goal of the company, even though people may express excitement at the onset of a project, that withers away quite fast if it's not moving a metric that people can be reminded of when it comes time to, build infrastructure for that data product, staff up that data product beyond the single data scientist that might be there in the initial stage, and so on and so forth. So that's where I see the main struggle in my experience.
But when you're talking about trying to frame or scope the project right, something that aligns with the company, or like the, one of the bigger goals of the company. Let's say you're a retail company, right? Would it make sense if one of your goals is, well, we want to decrease cart abandonment rate? And then so you try to build maybe a chatbot or something like that that can answer questions and sort of talk to customers about certain products that are in their cart, and try to help them, make an informed or better decision. So would that maybe be how you envision companies coming up with ways to inject machine learning into what they're doing?
Yeah, that's a really good example. And I think, being able to describe that justification to business leadership in a crisp way, and inform folks of what is the opportunities of this data product, and what you might miss if you don't do anything, what opportunities might be left on the table, and really summing it up in terms of things that they care about. And really trying to find out, like, what is the bottom, what are the metrics they care about. A lot of times organizations have slews of different metrics, or even metrics you can make up, but you really have to find out what are the metrics this organization cares about. So I mean, in your example, it might be that there is some outstanding dashboard or report where they do measure abandonment rate, but you might have to also express that in terms of revenue, and do an analysis and paint a picture of how you might be able to move your quarterly numbers in one direction or the other with these type of things. And I think that's where people struggle, and frankly, that's where it gets lost. And that has nothing to do with ML ops. That's just where I see a lot of challenges. I think it's when you start to get into the actual implementation of these things, and that's where ML ops can be helpful.
Okay, that's interesting. Yeah. So you mentioned, some of the biggest challenges that you see are at the beginning of the project in the scoping phase. What are, I'm curious to hear, like, some challenges that you see, in production?
Yeah, I mean, I think so. A lot of times, models never make it to production because the process is so expensive and so onerous that never make it beyond the prototype stage, because folks underestimate the expense of putting something in production, or may not have tools or infrastructure in place to do that in a low cost manner. A lot of times, there's an upfront cost of building this infrastructure, having a platform where you can deploy these models. But a lot of companies, are reluctant to kind of do that. They kind of just jump right into, okay, let's just, deploy a model. And that first use case or that second use case can be quite expensive from an upstart perspective. So I think that's where people struggle. Folks struggle also with really the whole DevOps aspect of how to monitor, how to deploy, how to serve a model, how to deal with feedback loops, retraining of models, simple things even like how to track your various different experiments. I think there's almost nothing I can think about that is easy.
Yeah.
There are some things that I think are easy, but for most, I would say there's a large amount of surface area where there's not really any standardized tooling yet.
Mhm. Yeah, no, that's interesting. So, I mean, that probably brings us to what you do right now at GitHub, right? Which is try to make machine learning really work in production and make it work reliably. So, can you talk to us about some of the projects that you're working on right now, and why, how you think they might be useful to data engineers or developers working on NLP applications?
Yeah. So making machine learning work in production reliably is a very large surface area. So I don't want to pretend like I'm have any magic solution to fix all of that. Instead, what I try to do is try to make parts of it easier one step at a time. And so what I mean by that is, as I mentioned before, the kind of discipline of ML ops, taking DevOps kind of ideas and applying them to machine learning, and try to find opportunities and using tools that GitHub provides to try to bring some of these DevOps ideas into machine learning. So what I mean by that specifically is there's a lot of DevOps in Git or GitHub in terms of especially things like CI/CD tools. So things like Travis or Circle CI they might be used to for a long time. Things like automated testing, running code for you, logging it, even deploying from GitHub. And so GitHub recently in the last couple of years released GitHub Actions, which is a native way to run CI/CD on GitHub using a product that GitHub provides. And so what I've been doing as a machine learning engineer is finding pain points I personally have and making example workflows and other hosted actions that people can use in their machine learning workflows that kind of brings DevOps to machine learning. So things that, for example, just to give you some examples, so GitHub Actions that can help you test your models when you open a PR, or test your data when you open a PR, or some integrations with Jupyter such that you have you can get a binder shortcut to Binder Hub with the right dependencies installed, and some other things along that line. And there's some special aspects about GitHub Actions that makes it easier. So the cool part about GitHub Actions is it makes it to where you can host a pre-packaged workflow for someone else. So if I figure out how to do something really complicated, like log to an experiment tracking, or let's just step back. So if I figure out a process where you can take a configuration file, use that plus code to train a model, log that to some experiment tracking system, and then at the end of that, bring those results back into a PR. That can be really complicated. Like I have to use 3 or 4 tools to do that, but I can package it all together and abstract it with an API and say, okay, these are the inputs I expect. These are the outputs that will be emitted from that. And I can host that as a GitHub action. And then people don't have to fiddle around with all of these tools, they can just use that in their workflow. And it can be kind of like an abstraction. So it allows you to build these abstractions. And so I've been partnering with some open source projects to build some abstractions like this for machine learning workflows, if that makes any sense.
Yeah.
So there's one really simple one is there's something called Repo to Docker. So a lot of data scientists, they're not comfortable with Docker, which is understandable. And so there's a really cool project that Binder Hub uses called Repo to Docker, which takes a GitHub repository, or really any repository, and it Dockerizes it based on some smart rules about looking for configuration files. And so there's a GitHub action, for example, that will do that for you automatically. That will Dockerize your GitHub repo and push it to a Docker Hub, so that you always have an image that's up to date, even if you don't understand Docker. So there's all these things like that, and the hope is with all of these tools, with enough of these tools out there, you can compose them together to then start to make a difference in your machine learning workflow and kind of make it easier for you to do things. But it's definitely a large surface area. So there's definitely a lot of things that don't necessarily that really don't have anything to do with GitHub, or parts of the machine learning workflow that don't involve necessarily changing something on GitHub. And I haven't really tackled too much of that so far, but that is something else. There is something else I've been working on. So I'm generally interested in making tools for data scientists in general. So one thing I was frustrated with is how hard it was to blog with Jupyter notebooks. So like, I don't know about you, but when I write a blog that involves code, I do use a Jupyter notebook or something like it to kind of draft my text, and then I have code in the blog. So I want to test that the code works and that it is cohesive with the writing. And so Jupyter notebooks is like the best thing for this. That's what it's designed for. It's designed to be this thing where you have code and text together in one place, and then you can just run it. It's very natural, but then converting that to a blog, I found it to be very painful, just out in the wild. All these like fiddly conversion scripts, and I have to learn about web hosting. I learn something about static site generators. I have to learn HTML, CSS. I had to learn about GitHub Pages, how to deploy that, and then like 10 other things. And so I made this thing called Fast Pages, which allows you to save a notebook into a repository in GitHub, and it just becomes a blog. So we did that in partnership with Fast AI, which is a community that I like to contribute to, cool. to make that easy. So that's some of the stuff. Like generally, it's not all about GitHub Actions. There's also some stuff that I'm doing with this product called Code Spaces, that is a development environment in your browser. Like, but I haven't talked about that yet. But basically, anything that you can, any dimension on which GitHub can make it easier for data scientists, I like to try to find ways to bring that forward. So it can be GitHub Pages with the blogging. It can be Actions or Code Spaces or whatever. I'm interested in all of that.
Just switch gears to Fast Pages a little bit. Where is that available if developers wanted to look that up and take advantage of that?
Yeah, it's GitHub. It's on GitHub, so it's under Fast AI /Fast Pages. Cool. If you go to Fast AI, it's pinned on one of the repositories at the top, and you can see that.
Okay, sweet. Yeah, I definitely want to check that out. So I didn't know about that.
Yeah, definitely.
Yeah. Also, going back to GitHub Actions, is there a way to do to run diagnostics or do diagnostics as part of the CI/CD pipeline?
Yeah. So so Actions allows you to run arbitrary code triggered by anything that happens on GitHub. So opening a PR, making a comment to PR, making a comment to an issue, labeling an issue, whatever you can think of, you can have a GitHub action that runs in response to that. And so, and they're quite flexible. Like you can do anything. And so, and you can also have self-hosted actions where the runtime of the action is privately hosted by you, so that you can run it in your own data center or in your own private network or bare metal, and you can connect it to your data sources. So, for example, what that means is you can. So we have workflows that we have demonstrated where you can open a PR, and if that PR changes some code that deals with the model of any kind, then you can submit a test run that does a full test run of that model on your own infrastructure, and it logs it to an experiment tracking system. And then when that full run is done, it brings back all the metrics of that run into the PR. And then you can also optionally compare it to a baseline and say, okay, I changed. So the point of that is like you change something about a model. Not only do you do your typical unit tests to see if the code works, but you also want to make sure this model kind of is acceptable before you merge it into your master branch or your default branch. And so that's one way you can do it. And we have some demonstrations of that in videos of that if anyone's interested. You can find that there's a lot of different ways you can find that. You can just Google generally, and some of the top results will be stuff I'm talking about. But there's a microsite called mlops-github.com, and then try to collect a lot of the information there.
Okay, cool. Do you see a lot of teams using GitHub Actions for exploratory use cases right now, or do you see that happening in production with teams?
For machine learning or just
Yeah.
generally? Machine learning. It's hard to say. Like I don't talk to too many. So and maybe I've been in touch with 10 to 15 different companies that have been using this GitHub Actions and these MLOps things internally. So it's hard for me to know exactly who's using the actions because I don't actually have tracking information on the ones that we create. So yeah, unfortunately, I don't know too much about that, but I do know that a lot of people at least these people that have reached out to me, there are people that are interested in using this, and they are using it. So in that sense, it's promising.
Cool. I know that you've been, because I was reading your blog, and I know you recently wrote a blog post about Great Expectations, which is another product that I think you're working on. If you want to talk about that,
Yeah, I think Great Expectations is really exciting because it's the first CI workflow that I've ever seen that tests your data. There's no such thing before Great Expectations that is CI for data. That just didn't exist. That wasn't a thing. Like there's no way right now today CI is only used to test your code on GitHub, but there's no way before Great Expectations to reliably test your data. And you might be wondering, as I say this, like, how do you test your data on GitHub? That doesn't even make any sense. Like you don't store your data in GitHub. That's true. And so all these considerations have been thought of. And so what Great Expectations does is it has configuration files that allow you to connect to your remote data sources. And one of the problems with generating unit tests for data is historically is kind of very time consuming and very painful, because if you imagine taking a unit test for data, you have to sit there and create all these rules. Like, okay, this column has only unique values, and this other column is range should only be between this and that, and this column has a statistical distribution of X, and blah, blah, blah. And you have to sit there and brainstorm, and it's like this process of writing all these tests. And you have to think deeply about what, doing that across all of your data is like maybe several-fold full-time employees doing that all day long. And that hasn't been realistic. So the approach that Great Expectations takes is they profile your data. And so they bootstrap you with a bunch of rules. And then you can quickly go in and edit those rules. And that's a great way to get started really fast. And so they generate all these unit tests, and then you can quickly, in very short order, sort of connect your data to Great Expectations, which is an open source project. And while data isn't not currently being stored in GitHub, people still write their code for their data pipelines. So things like Airflow or even SQL queries or whatever it may be, people routinely do store that in GitHub. And so what's really useful to know is if you do change your code in a pipeline, your data pipeline, does it break your pipeline? Did you mess, beyond breaking something, did it change the data in a way that is unexpected? And so that's really useful. Now, your data pipeline can change, or your data can definitely break as a result of things, and that has nothing to do with you changing your pipeline. But it's still useful to know if the code you changed broke your data pipeline, which does happen a lot. And so this allows you to do that. And you can also use Great Expectations to do other cool things. So if a non-code change does break your data pipeline, you can open an issue automatically on GitHub, when it does break, and say, hey, this table all of a sudden has these three situations where expectations are broken. This column all of a sudden has missing values. This other column, has this outlier and all that stuff. And so that's really important. I think the reason it's really exciting is because a lot of people spend most of their time with the data. There's a lot of focus on modeling, getting the modeling right, the serving right, so on and so forth. But there's not any tools. There's not many tools that help people with this DevOps for data. And I think that is a really interesting, it's very unique, and it's cool, and I think it's really helpful. And it can be used even if you're not doing ML. If you're just maintaining a data warehouse, it's very useful for that as well. So yeah, I think it's really interesting in that sense.
Cool. How do you envision that being used for something conversational AI, for instance? I mean, I've yet to check out Great Expectations, so I don't quite know how that works in real life. But how do you see that working for conversational AI applications where a lot of the data that you're collecting are user conversations, right? So then you could try to study and review those user conversations in production, use those insights to make your assistant better. How would you use, that data within Great Expectations?
Yeah, I mean, so I think something like Great Expectations is more useful with more of a tabular type of data set, and with the unstructured data like text. I think you would still want to use Great Expectations, but you definitely want to be thoughtful about it. Yeah, you can't just necessarily just throw it at Great Expectations without just out of the box like you can with more tabular data. And so I think calculating some statistics about your data on a row level can be really useful, like the length of these texts and other statistics that you may want to sort of just monitor in a way, so you can kind of catch things that shouldn't happen. But it is more challenging. Like for something like Great Expectations, if all of your data is unstructured, then it may not be as useful. But imagine a conversational AI system is not just text anyway. Like a really good one has a lot of tabular data that is associated with the text.
Right.
And so in that sense, I think it's still useful. So that's kind of my high level thoughts on that.
Like, I mean, I guess if you were maybe doing a survey or something with a chatbot asking those questions, or giving the user like a lot of rich text buttons and things like that as input, maybe trying to collect that and then do some kind of higher level analysis based on that data. Maybe that
Yeah, I
might.
mean, I think that a good conversational agent is probably using a lot of tabular data as well. Like, there's likely is a lot of like user information and other metadata that you have, you know, that your models are using in addition to like what is happening in the conversation. So, for example, like if once the user signs up, maybe they give you some information. Maybe there's some other activity that the user is doing. Like if it's on a retail site, you might have some other purchasing data about that, page views, things like that. There's all kinds of other contexts you might need to consider. These conversational agents don't exist in a vacuum, as you know. And so, in that sense, I think it's probably useful for most people. Um, Even so, I mean, I don't see too many use cases where it's just text data on its own in isolation, but there certainly is stuff like that. But that's just my experience. I could be wrong.
Okay. Yeah, no, that's definitely very interesting. I mean, we like to talk about how, you need like lots of stuff to build great conversational AI, right? You need great research for sure. You also need to implement things like, at Raza, we like to talk about conversation driven development a lot, which is, a set of practices where you listen to users, review those conversations, that feedback, and then you use those insights to improve your AI system. And you definitely need things like sound engineering principles, like right, so like CI/CD testing and using things like Dockers and a microservices architecture where and if it makes sense. So you basically need tools just like you would for any other software application. Um, and we're all trying to get to the next breakthrough in conversational AI. I'm curious to hear your thoughts on what you think the biggest challenge is for getting something like conversational AI or other machine learning applications too, to get to the next level, and how you see open source contributing to solving that next challenge.
Yeah, so I'm actually not a conversational AI expert. I have fiddled around with a lot of NLP. That's my definitely my primary uh, focus area in machine learning. However, when it comes to conversational AI, it's a little bit elusive, like in the sense I don't, I haven't really seen anything in the wild as a consumer that I've been impressed with, to be quite honest. So it's hard for me to map onto. I still remain a little bit skeptical as to if the current methods are going to really do anything that is a step change. But I could be wrong. I just don't. I'm not really focused on the conversational aspect of things. Um, and so, yeah, I mean, I guess I do remain skeptical that even something like GPT-3, which
Right.
is really cool, I still remain skeptical, even if you had GPT-3, using GPT-3 as an API in your application, like how useful it would be in a product, for in a conversational sense.
Mhm.
Um,
Yeah,
and
definitely.
so, yeah, that's kind of. There are some small things that I could see conversational AI helping with, but I think that you, I'm kind of still waiting for that example where I feel that it's working. The efficacy is high enough to where I feel like it's actually reducing some kind of burden.
Right.
Um, so as far as yeah, I think open source is really great. I think it really allows people to have an open discussion and try to collaborate with each other and move the discussion forward. And things like GPT-3, the reason why I think that could be really interesting is, there's a large movement in open source, for example, with GPT-3 to make that more accessible. Even though the model is obfuscated behind an API, there's a lot of people working on how to do something similar with less compute. And there's already some papers out that sort of kind of tackling that idea. And I think open source is a big part of that, to sort of allow people to feed off of each other's ideas, and make things that are practical. So I think it's really important.
Yeah, I mean, how important is open source, would you say, to GitHub and what you do?
Yeah, I mean, I think GitHub, is really intertwined with open source. I think that's where the open source lives to a large degree. And I think a lot of people associate GitHub with open source for a good reason. And yeah, it's very important to what I do. I think whenever I try to make any ML ops project, I do it in cooperation with an open source project like Great Expectations, or like with Jupyter or Fast AI, just because those are the places that I can get a lot of feedback, and also want to use open source projects because I know that people are more likely to use those. And just want I'm kind of using open source the same reason anyone else uses open source. I just want to build on stand on the shoulders of all these giants building all these things instead of building them myself.
Right, very cool. If people wanted to get in touch with you to ask you, questions about Fast Pages or GitHub Actions or Great Expectations, how can they do that?
Yeah, you can go to my website. It's hamel.dev, and then that's just a page with some links to some of my work, and then it has my contact information there. And you can just get in touch with me through one of those avenues.
Okay, cool. Yeah, we'll provide a few links on how to get in touch with you, and also link to some of the projects that you referenced. But Hamel, thank you so much for chatting with us today, and really thank you for your time.
Yeah, thanks a lot. Thanks for having me.
Welcome to Rasa Shoutouts, a segment where we like to acknowledge and thank our amazing community. First off, we have a new Raza hero. Cobus Grayling has written 8 incredible articles on Raza, and 2 of them have actually been translated into Spanish in just the past few weeks. Cobus really fits the bill when it comes to consistent, high-quality contributions and meeting the requirements to become a Raza hero. Congrats, Cobus, and thanks for all of your support. And now we're going to recognize some exceptional contributions. Paul Louis Neck, Musa Atlihan, Tim Venk, Norbert Verzeren, Pranav Durai for their code contributions. Thanks to Yurio Windiat-Moko, Ahmed Fatan Hayatullah, Rido Ahmadi for their citation on developing Facebook chatbot based on deep learning using the Raza framework for university inquiries. Mayresh Shiloter, co-founder of Grey Atom, he actually shared a video tutorial on how to make a chatbot using the Raza tech stack. Shout out to Gaurav Sharma and A. Anand for their incredible support on our community forum. Shout out to Rakesh Panagrahi for his written tutorial series, A Practical Guide to the Rasa Chatbot. Shout out to Simone Cardis for his talk on Introduction into the World of Chatbots and NLP at the Download Innovation Conference 2020, delivered in Italian. Wei Feng for his incredible guide on what's new in our next major release, Raza 2.0. And last but not least, thanks to William Arias for his video talk on deploying your chatbot using CI/CD. And that's it for this week. Thanks for tuning in. We'll see you in a couple of weeks, and in the meantime, come hang out with us on our forum.